Hello everyone, my name is Aarohi and welcome back to my channel. So guys, in my last class we understood what NumPy is and why NumPy arrays are faster than Python list, and then we also covered few important concepts like array properties, indexing, slicing and vectorization. Now today we are going to learn the next important concept in NumPy, which is broadcasting. So guys, this concept is very important because it is used in almost every AI and deep learning algorithm. So what is broadcasting? Broadcasting in NumPy simply means that a smaller array are automatically expanded virtually to match the shape of the larger array so that we can perform operations easily on the arrays. Let me explain you this with the help of example. So suppose we have this 2D array where we have 3 rows and 3 columns. And we have another array which is a 1D array, means all the elements are there in a single line. Now, with the help of broadcasting, NumPy can expand this 1D array into a 2D array so that it can match with the shape of 2D array, and then element-wise operation can be performed easily without manually reshaping the arrays. But guys, remember one thing, that broadcasting does not actually convert this 1D array into a 2D array. Broadcasting is basically treating this 1D array as 2D array. It is not actually reshaping this 1D array. Now let's see this same example practically. That will give you more clear idea that what is exactly happening in broadcasting. So we will do our code in Visual Studio Code only. So let's open that and do the work. So open VS Code. And so guys, in our last class, we created one folder with the name of NumPy tutorial, and inside that folder, we did all the tasks related to NumPy. So today we are going to work inside this folder only. So you just create one new file, click on this new file and name it broadcasting example.py, enter. Now we have this blank file. Here we are going to work. So let's create one 2D array. So before that, import NumPy. Now we will create 2D array. How we create array? Now np dot array, then parenthesis, then you will write square brackets, and inside it we are going to create a number of rows. So one list means one row, second list is second row, and third list is third row. Each inner list means one row. Now let's write numbers inside it. So we have these 3 numbers in the first list, in the first row, second row, okay. So this is our 2D array. Now let's create one 1D array. So you will again write np.array, parenthesis, and then square bracket, and here write, let's say 10, 20, 30. So this is our 1D array. 1D array simply means we have all the elements in a single line. And 2D array means we have data in the form of rows and columns. So we have 3 rows and 3 columns. Now, if you want to perform mathematical operation on it, let's say you want to add this 2D array with 1D array. This is what you want to do. Okay, before this, let me show you the shape of both the arrays. So write print ar1d dot shape. Let me just copy this, paste it here, change the name. Now let's just run this file and see the shape. So our file name is broadcasting example.py. Run it. See, the shape of 2D array is this, and the shape of 1D array is this. What it means? This simply means that we have 3 elements, and over here it means 3 rows and 3 columns. And now let me just uncomment this line and print the output. So here, when you will add 2D array with 1D array, NumPy will internally use broadcasting concept. First, let's see the output, then I'll show you step by step what is actually happening here. So, save this file and run Python broadcasting example. See, this is the output. Let me just write this output here. Now let's see what is actually happening. So we have 2D array and we have 1D array. Now 2D array is the largest array, right? And 1D array is a small array. To add these two arrays, NumPy will expand the 1D array so that it match with the shape of 2D array. So that means this 1D array, what is our 1D array? This is a 1D array. So how broadcasting will work? Let me just write here. So this is a 1D array, again 1D array, again 1D array. So this is what exactly happening here. So NumPy is writing or repeating this 1D array how many times? It will repeat this 1D array as per the number of rows which are there in this 2D array. So in this 2D array, how many rows we have? We have 3 rows. So using broadcasting, NumPy repeated this 1D array like this so that it matches with the size of 2D array. Now mathematical operation can be performed. We have one array this and the other array is this 2D array. Now this 1D array also became 2D array. It matches with the shape of 2D array. Now element wise addition can be performed easily, right? So this is what broadcasting is. Broadcasting simply means NumPy will expand the smaller array into the shape of a larger array so that element wise operations can be performed easily. But guys, remember, it is not actually converting this 1D array into a 2D array. It just behave as if it did, but it does not actually convert it, and this saves memory because no extra copy is getting created and computations will be faster. Why computation will be faster? Because NumPy operations run in C language, which is a low level language. Means Python is a high level language, right? We are writing our code in Python and it is easy to write, but Python is slow when you run it. And NumPy is written in C, and C is a low level language, means it is fast. So when we write this code to perform addition between two different type of array, we are writing our code in Python, but the actual computation will happen in C because NumPy do all the calculations in C. Here Python is just saying that add this 2D array with the 1D array. The actual calculation is getting done using the C language because C language is getting used by the NumPy. So this is what broadcasting is. Now let me show you a few more examples so that you can understand this concept clearly. So let's create a new file and name it broadcasting example 2.py and import NumPy and create one array. So let's say we have one array, np.array parenthesis square bracket, and we have these 4 values in the array. Now let's say we have another variable b, and inside that variable we have only one single value, means scalar value, single value. So we have one array and we have one variable. This variable have 10 in it. Now let's say I want to add this array with the scalar value. So array a plus b. So what will happen when we run this code? So NumPy will use broadcasting. Why and how? B is a scalar value, single value, but in A we have 4 elements. And we want to add this 10 with this. Means we want to add 10 with 1. Then we want to add 10 in this, 10 plus 3 and 10 plus 4. This is what we want to do. We want to add 10 with each element of the array. And for that, broadcasting will be used by NumPy, which simply means, what is broadcasting? Broadcasting will make the smaller array equivalent to the larger array. It will expand the smaller array in the shape of the larger array so that element wise operations can be performed. But we have one array, and here we have a scalar value. Scalar value, single value. That means, okay, let's just check the shape of both. So here you will see the shape, you will get the shape. But in B, you will not get the shape because this is a zero dimensional array. Okay, so this is a zero dimensional array and this is a 1D array. So when you will see the shape, here you will get output this. This will be the shape. But here you will not get any shape. Even if you will try to run b.shape, you will get an error. Okay, let me show you. Let's just comment this part for now and check the shape of arr underscore a dot shape. Let's just print it. And then let's check the shape of B. We will get error, but still I want to show what kind of error you will see, because B is not an array and this shape function we use on arrays. B is a zero dimensional array. It is a scalar value. Okay, so let's just run this code. Python broadcasting example2.py, run it. See, first, what is this? This is a shape of this array. What it means? It simply means that we have 4 elements in a single line. And then we got this error. What this error says? Int object has no attribute shape. Because we have an integer value in a variable, you cannot use shape function on it because shape functions you use on arrays only. So for now, just think that we have no shape, we have blank parentheses. Here we have 4 because there are 4 elements, and suppose here we have no elements. And when there are no elements, at that time NumPy will provide one value to it. Okay, so just remember this thing while performing broadcasting. If you have a scalar value, means you are using a zero dimensional array and you don't have any shape because this is a zero dimensional array. So when there is no value, NumPy will provide it one value. Okay, so here we have this shape now and here we have this shape. Now to perform the addition between this array and this B, NumPy will use broadcasting, means it will repeat this 10 how many times? It depends upon the elements which are there in the larger array. So in our larger array, we have 4 elements. So it will make B, it will expand B like this. So when you'll use broadcasting, B will become this 10, 10, again 10, and then 10. So why 4 times 10? Because the other array which we have 4 elements. And guys, again remember that NumPy will not actually convert this scalar value into a 1D vector. It will just treat it as a 1D vector. It will not actually reshape the B variable to a 1D vector. Okay, I am just writing it over here because I just want to show you the actual idea that what is actually happening behind the scenes when broadcasting is getting used. So now we have 4 elements in B. Actually it is 10 only, but virtually or conceptually NumPy will have this kind of vector for B. Now we have 4 elements in B and we have 4 elements in A, and now you can perform this addition. Okay, let's just print it. Save it and let's run it. Clear the screen first and then run this file. Okay, let me just remove this line because this line is giving us error. Clear the screen and run the code. See, output is 11, 12, 13, 14. Why the output is 11, 12, 13, 14? Because output is this 11, 12, 13, 14. B is 10. So 10 plus 1 is 11. 10 plus 2 is 12. 10 plus 3 is 13. And 10 plus 4 is 14. So we got this output. Guys, again, as I've told you in the last example also, that NumPy broadcasting will make your work fast and easier and more efficient. How? Because NumPy is running in C. C is a low level language. It will run your program fast. And we are writing our code in Python. Python is just saying add this array with this b variable. That's it. This instruction Python is giving. But the actual mathematical calculation is getting happened using NumPy, and which is running in C, which is low level language. That's why it is fast. Now let's see one more example. So create a separate file and name it broadcasting example 3.py. Now import NumPy as np, create first array. So we are first creating a 1D array. So you will write np dot array parentheses and in square bracket just write 1 2 3. So we have this 1D array. Now let's create second array. So this time we are creating a 2D array. So np dot array parentheses and then square bracket, and here create one list, comma, another list, comma, and then another list. So 3 inner list simply means 3 rows, and here I wrote 10 and here 20 and 30. So this is a 2D array. We have 3 rows because we have 3 inner list, and each row have one element. That means one column in each row. Now let's just print the shape of both the arrays. Print arr a dot shape, and then just print arr b dot shape. Okay, let's just print their shape. So Python broadcasting example 3.py. So the shape of 1D array is this, and the shape of 2D array is this. What it means? That there are 3 elements in a single line. So that means single row, and in that row we have 3 elements. And array.b shape 3 1. What it means? That 3 rows are there and each row have one column. Now if you want to perform addition on these two array, arr a plus arr b. Now if you want to perform addition on these two arrays, so what will happen? NumPy will first check their shapes. NumPy will see, okay, array A shape is this and array B shape is this. So the shapes are not matching. Element wise addition cannot be performed. So it will first use the concept of broadcasting to make their shape equal so that addition can be performed. So what will NumPy do? How it will perform broadcasting? Let's see that. So I'm writing inside this block. So first it will repeat this 1D array how many times? 3 times. Why? Because there are 3 rows in array B. Okay, so this is what it is going to do with the arr A. And then in array B, there is only one column in each row. But in array A, how many columns we have? Like this is a 1D array and this is a one row, and in that row we have 3 columns. But in array B, we have one column in each row. So it will repeat each column. In array B, what will it do? It will repeat this 10 3 times. Then it will repeat 23 times. Then it will write 33 times. See, now NumPy is internally expanding array A as this. It is expanding the rows of array A because array B have 3 rows. And NumPy is internally expanding the array B across the columns so that it matches with the columns of array A because array A has 3 columns. Now mathematical operation will be performed on these two arrays and we will get the outputs. So let me just paste this part over here. This is array A, this is array B, and here element wise addition is happening. And now let me just print this output and you will see the output, this output. Okay, save it and run it. Python broadcasting example 3. See, 11, 12, 13, 21, 22, 23, 31, 32, 33. This is the output. So this is what broadcasting is. And at what step broadcasting is happening? Broadcasting will happen at this step because when you will write add array A and array B, NumPy will see, okay, the shapes are not matching, so I need to use broadcasting. And it will expand the array A like this and array B like this. Okay, and then it will perform this operation. So this is what broadcasting is. And now guys, let's suppose you are not using NumPy, you are not using broadcasting, and you want to do this process in Python. Then what will you do? I'm just pasting the code. I'm not going to waste time on writing this part. So I'm just pasting it over here just to make you understand. See, let's suppose you want to do the same part with Python. So this is what you will do. If you want to add this array A and array B, these two arrays, suppose these two arrays you want to add using Python, then what will happen? Okay, let me just write it here. Python. Okay. So now we have same array. You want to do the task with Python. So you will use a for loop and we will run the loop. How many times? It will depend upon the elements in the array. And we are using a for loop and then nested for loop, and then we are adding those values manually, and all these tasks is happening in Python. First of all, I've told you that Python is a high level language. So if you are running this code in Python, so Python will take time. Python is slow. So you are doing all the calculation in a manual way using Python. And the concept of vectorization is not getting used because in NumPy, I've told you in my last class that the concept of vectorization is getting used. Vectorization simply means when all the task is getting done on arrays in a single go. You are not doing steps one by one. So over here, the first element of first array will be added with the first element of second array in one loop. Then in the second loop, the second element of first array and the second element of second array will be added. And then in the third time, the elements of both the arrays will be added. So the task is getting executed one by one. But in NumPy, using vectorization, all the task is getting done in one go. And it is running in C, so it is fast. And if you'll do the same task with Python, it will be time consuming. So I just wrote this example for you so that you can compare it. I'm commenting it now. Save this file. Now guys, let me share one example of deep learning where this concept is getting used, because in the beginning of our today's class, I have told you that this broadcasting concept we use almost in every AI and deep learning algorithm. So let me share one example with you where broadcasting is getting used. So let's create a separate file for it. So create file and name it AI broadcasting example.py. Here's in deep learning, now there is one formula. See, output weights multiply by input and then we add bias in it. So X means input, W is weights. So if you don't know anything about AI and deep learning right now, so just think that there is one algorithm and over there we use this formula, the formula of linear algebra. Inputs, X is input, weight we multiply weights with input, and then we add bias in it. So this adding a bias when we multiply input with the weights, over here the concept of broadcasting will be used. I'm not going to explain you this in detail because then I have to explain the entire algorithm to you first, and I just want to give you a basic idea that how broadcasting is getting used in AI and deep learning. So this is one of the very initial and basic algorithm which we use in deep learning, where we use this formula of linear algebra, and there we add bias with this using the broadcasting concept. Now there are some rules which NumPy follows while performing broadcasting. Let me explain you those rules. So create a separate file for it and name it broadcasting rules. So suppose you have two arrays. Okay, so you have one array A, and the shape of this array is 4 comma 3, means 4 rows and 3 columns. Let me write here 4 rows and 3 columns. And then you have another array with the name of B, and there are 3 elements in a single row. Now rule number 1 is that compare from right side. First align them from right side. Let me explain you. So first is A, so just copy it here. So A is 4 rows and 3 column. Now B is this. See, I have aligned the B on the right side. See, this is the first rule. So you will write the shape of both arrays, and then you will always start from the right side. So the shape of B is like this over here, but over here I wrote it like this, means I started from the right side. So this 3 is on right side, and this 3 of B is also on right side. Now there is nothing below this 4, right? On the left side there is nothing, and when there is nothing to compare with, means A arrays 4 and we don't have anything over here in B, then NumPy will put 1 over here. So we can write it like this. So the shape of A array is this and the shape of B array is this. NumPy used 1 at the place when there is nothing. Now we can compare, this 3 can be compared with this 3, this 4 can be compared with this, right? This scenario is correct. Broadcasting will work in this scenario. Okay, this is one of the scenario. Guys, I'm telling you, I'm teaching you the rules how broadcasting happen. You cannot perform broadcasting in every scenario. Right now I'm teaching you in what scenarios broadcasting can be done and in what scenarios you cannot use broadcasting. So rule number 1, I have explained you that while performing broadcasting, the shapes of arrays will be aligned from right side, and this will be compared with this, and over here there is nothing in B, so NumPy will use 1. Now 4 will be compared with 1, 3 will be compared with 3, and this scenario is right scenario. You can perform the broadcasting. This is one rule. So from here we learned two things. Rule number one is when the numbers are same, then you can perform broadcasting. So this 3 over here in A and 3 in B is same. That means broadcasting can be performed. This is one rule. Second rule is, let me just write it like this. See, now the second rule is we use this 1 over here and now we can stretch it. I have already explained you, we expanded the smallest array into the shape of the large array. So this 1 is small, so it can be expanded. So this scenario is also okay. Now let me tell you the third rule. So suppose this is the case. For example, you have array A. The shape of that array is this 4 rows and 3 columns. And you have array B. The shape is 2. And I've told you that we need to align them from the right side, as I've shown you in the first example. See, like this from right side. So let's align it. So when we aligned it, this 2 will be moved to the right side over here, right? So that is what we have done, 2. And when we moved 2 over here, there is nothing below 4. So NumPy will put 1 over there. Now, this 3 is not equal to 2. That means you cannot perform broadcasting. So this is the next rule, third rule. Over here in the previous example, A dot shape and B dot shape. So over here we have 3 and in B also we have 3. So these two numbers are matching. So that's why broadcasting is possible. But here we have 3 and in B we have 2. So these two numbers are not matching. That means broadcasting is not possible in this scenario. In this case, 3 versus 2, they're not equal and they are not even 1. So you will get an error. So in this scenario, you cannot use broadcasting. So guys, this is what you need to know about broadcasting. So I hope this video is helpful and I have provided the link of this code in description section. You can get this code from there. Thank you for watching.